Hello everyone and welcome back to my channel. In today's video, we will be diving into some interesting stack problems in Python. If you are new to stacks, don't worry, we will go over what stacks are, how they work and tackle two important problems that can be solved using stacks, which are balanced parenthesis and reversing a string. By the end of this video, you will have an understanding of how stacks work and how to apply them to solve real-world problems. Let's begin by quickly reviewing what a stack is and how it operates. A stack is a linear data structure that follows the LIFO, which is last in first out principle. This means that the last element added to the stack is the first one to be removed. Think of a stack as a pile of books. The last book you put on top is the first one you will take off. The two main operations that a stack supports are push operation, adding an element to the top of the stack, then pop operation, removing the element from the top of the stack. Stacks are widely used in scenarios where you need to reverse things or manage a nested structure, such as parentheses in programming or undo operations in text editors. Let's start with our first problem, balanced parentheses. The problem is simple. Given a string containing characters like parentheses, braces, and brackets, we need to check if every opening parenthesis has a corresponding closing parenthesis and if they are in correct order. To solve this, we will use a stack. The idea is to traverse the string character by character. Then if the character is an opening bracket, then we push it onto the stack. And if the character is a closing bracket, we check if the top of the stack matches the corresponding opening bracket. And if it does, we pop the stack. Otherwise, we return false. At the end, if the stack is empty, the parentheses are balanced. If there are still unmatched opening brackets in the stack, the string is not balanced. Here's the Python code to implement this solution. So let's break it down. First, we create an empty stack to keep track of the opening brackets. So as we loop through the string, if we encounter an opening bracket like this, then we push, which means we will append it to the stack. Then if we encounter a closing bracket, we check if the stack is empty. And if it's not empty, we pop the stack and check if the top element matches the corresponding opening bracket. So we check if the stack is empty, and if it's not empty, we pop the stack and check if the top element matches the corresponding opening bracket. And if it doesn't match, we return false. After processing the string, we check if the stack is empty. If it is, all parentheses are properly matched and we return true. If not, there are unmatched opening brackets, so we return false. Now let's move on to another problem, which is reversing a string using a stack. The idea here is to reverse the order of characters in a given string using a stack. Here's how we can do that. First, we push each character of the string onto the stack. Then we pop each character from the stack and append it to the result string. Since stacks follow the LIFO principle, the order of characters will be reversed by the time we pop all of them. Let me show you the Python code to implement this. Here's how this works. We convert the string S into a stack by turning it into a list. Each character in the string is now an element in the list. We initialized an empty string, reversed str to hold the reversed string. Then we enter a while loop that continues as long as the stack has elements. Inside the loop, we pop the top element of the stack, which gives us the last character that was added. Then we append this character to the reverse string. That's the operation being done here. Then we finally return the reverse string, which is constructed by the characters popped off the stack in reversed order. So finally, we return the reversed string, which is constructed by the characters popped off the stack in reverse order. So why do we use stacks for these types of problems? Well, the stack's LIFO nature makes it the perfect fit for problems that require us to reverse elements or match pairs in a specific order, such as parenthesis matching. It ensures that we always deal with the most recently added element first, making it ideal for tasks like parsing expression with nested structures, reversing strings or arrays, undo operations in applications. To summarize, today we explored two important stack problems in Python. First one is balanced parenthesis problem, where we used a stack to check if the parentheses in a string are balanced. Then the second problem is reversing a string, where we used a stack to reverse the characters of a string. We saw that stacks provide an efficient way to solve these problems because of their simple yet powerful LIFO principle. Remember, stacks are useful whenever you need to process elements in reverse order or manage nested structures. That's all for today's video. In the next video, we will start with the queues data structure. If you found it helpful, please give it a thumbs up and subscribe for more content. Let me know in the comments if you have any questions or if you would like to see more stack related problems in future videos. And thank you for watching and happy coding.